Zero and negative exponents are something that you probably explored in grade 9. We need to understand them much more deeply in grade 10, and then even more so in grade 11. So, first of all, recall exponent laws. When I have x to the 7 divided by x to the 2, this means x to the 7 minus 2. I don't have to write this, but that's what I'm doing. And this is an x to the 5. This is what I simplify this to. However, when there are more x's at the bottom, right, this is 2 minus 7. This is x to the 2 minus 7, which gives me x to the negative 5. So this answer has a negative exponent. And what a negative exponent means, if I expand that up there, take a look at what this is. This is x and x on top. And 1, 2, 3, 4, 5, 6, 7. This x takes that one, this x takes that one, and I'm left with 5 x's at the bottom. So what negative exponents actually mean, it means that whatever has the negative exponents belongs on the other side of the fraction. In this case, at the bottom of the fraction. This is 1 over x5 over here. 1 over x to the 5. So that brings us to kind of conclude that, well, a negative exponent just means that it's 1 over that base to the positive exponent. We make a rule over here that says that x to the negative n is the same as 1 over x to the n. It does not change the sign of the base. It never turns negative or positive. It's just the negative exponent just says, hey, it's on the wrong side of the fraction. In math, we have two sides to like pretty much every number, the numerator and the denominator. Only two. If there's a negative exponent anywhere, it's on the wrong side. Move it to the other side. What about x to the 7 divided by x to the 7? We all know something divided by itself is 1. Well, it's 1 because the exponent over here is x to the 7 minus 7. This is x to the 0. Well, we know anything divided by itself is 1. And it's 1 because everything to the exponent 0 is 1. Other rule. 0 exponents always give us a 1. If you see a 0 exponent, it means you're dividing something by itself. So of course it's 1. Okay? But also can come with its own tricks and difficulties. So let's do some quick examples and then we'll be done. We want to evaluate all of these, ideally without a calculator. 4 to the negative 1. This is really a 4 over 1, right? It's that all math is two-sided, numerator and denominator. So if it's 4 over 1, then the negative exponent will turn this to a 1 over 4 to the 1. But I don't have to put the positive 1. I could, though. Not necessary. So I find the reciprocal. Here I have an exponent of 0. 8 to the 0, that's just 1 every single time. I don't care if it's a million to the 0, it's 1. 2 over 3 to the negative 3. Well, I don't want to deal with a negative exponent. So both of these technically take on that negative 3. So I have to write this back, upside down rather. And now I can give it a 3. So take a look at right there. There's a full fraction that all I did was change the sign in the exponent and I found the reciprocal of the fraction. And now I can apply 3 to the 3 is 27 and 2 to the 3 is 8 and I'm done. Okay, we don't like giving answers using negative exponents. We like doing math with negative exponents because I can use one line instead of two, but answers should always be positive exponents. Let's take a look at this one. Everything in here is to a negative exponent, so the reciprocal of that is negative 1 over 2. And now I can change the exponent to a 3. I know that negative 1 over 2 to the 3 is negative 1 over 8, but if you forget, you just apply the 3 to both of these guys. Be careful though, this is, I don't need the brackets here, sorry. This is only negative because this is a 3. If this was a 4, it would be positive. Remember, odd and even exponents. Done. 0 to the negative 2, you can think of 0 as 0 over 1. It's really 0 over anything. But if I'm flipping it, I get 1 over 0 to the 2, and I can't divide by 0. So this is a kind of a tricky question. The answer to this is actually undefined. Can't have 0 to a negative exponent. It means 0 needs to go in the denominator, not allowed in math. Negative 8 to the 0, you're probably thinking, oh, sir, you said everything to the 0 is 1. Wrong. Negative 1. Because only the 8 has the 0. Only the 8 has the 0. Okay? As opposed to if I had this is positive 1. So the difference here is a very big mistake that is made often. Okay? Two more. I have a fraction, negative exponent, flip the fraction, 6 over 5 to the 2, that's 36 over 25. Easy. Here I have a fraction with a negative sign, doesn't matter. This negative has nothing to do with this negative, and it never will. Okay, so try not to think about that. This is 8 over 3, it's negative, and now it's squared. Now this, unlike this, is an even exponent, so that negative is going to disappear, and I'm going to get 64 over 9, positive. 64 over 9. Okay, I'm going to do another just random example here, just to show you what it really means to have a negative exponent. If I have a bunch of letters somewhere, so this is just like a side example, like A5, B7, C, -8, D, 11. Here I'm going to have A4, B, -3, C, 6, and D, 2. Okay, easy.
You need to take attendance on...
Okay, so you could do exponent laws with the A and the A, the B and the B, the C and the C, but I like understanding it more visually. So I said if there's a negative exponent on a number, it's on the wrong side. So take a look at this. This B doesn't belong down here. It needs to go up there. And if it goes up there, the B's now have 10. Right? So I can write my fraction like this, and I just skip the A's for no apparent reason. But I know that B10 belongs up here, because the 3 at the bottom needs to join the 7 up top. So I'm not even thinking addition or subtraction, I'm just thinking movement. A5 and A4, that's an easy one, that's just A on top. Look at this one. C8 at the top? Absolutely not. You need to go to the bottom and join that C6, creating a C14 at the bottom. This 2 D's and 11 D's turn into a D9 on top. And I'm simplified all using positive exponents. I didn't really do anything. I didn't add or subtract. I just like moved things around and I simplified it. Okay, but really you're doing, you're taking these B's and you're saying B to the 7 minus -3, which is B to the 10. That's why you get a B to the 10. So, I mean, you could do it this way using exponent laws, but I feel like moving things on one side or the other just kind of seems a little easier. And that is 4.6.